In the previous section, we were looking at numerical expressions. In this set of lessons, we're going to look at algebraic expressions, or expressions that have variables in them. A lot of similarities, especially when we key in on the structure. And so I want to give you a few examples that I took from a blog called Math with Bad Drawings. This first example here, we have an expression, an equation, it says solve for x. And Ben Orlin on his blog said, this is what students see. And you can see if you zoom in, students see, oh no, a variable expression with parentheses. I hate parentheses. What if it comes out negative? I hate negatives. Maybe I can expand the expression, and so on. Not very helpful, but we see here mathematicians see a different story. They see I have something times something equals to 0. So one of these shady characters must be 0. So if you look back over here, you see, do you see the structure? I have something here times something here equals 0. So that means x minus 5 must equal 0, or x minus 7 must equal 0. And then x has to be 5, or x has to be 7. And this isn't the point of this lesson. This is just how we can use structure to our advantage. Let's take a look at another example of structure. Here's what's on the page. Looks kind of scary. Here's what students see. Yep, that's scary, right? But mathematicians could look at this differently and say, hey, this is just something minus 3 equals 8. And he says, I'll worry about this bit later. But if you look here, we do really have just this big something minus 3. And again, we're looking at structure here. We're seeing kind of the format or the structure of how the problem is set up. Yeah, if we knew x, we would have to do a number of calculations, but eventually we would get down to minus 3 equals 8. In this example, the textbook is going to go through and look at structure of an expression. And so here's an algebraic expression. You see we have, again, variables, numbers, they're being multiplied together, and so on. If we read through here, we'll see that when we do order of operations, the last thing we do is we add and subtract. And so it's helpful a lot of times to break expressions up into terms of the expressions. And terms are just basically the pieces that are broken apart by addition and subtraction. So in this example, we have two terms. 1,000 is the first term, and then we're subtracting the second term. You might say, well, there's another subtraction sign here. And that's true, but then we're kind of looking at a term within a term. And so instead, we're just going to look at terms as having two terms here. The other thing to look at is a lot of times we have numbers that multiply times the rest of the terms, and that's called a coefficient. So in this case, we really have one coefficient, and that's this 10 right here. So this 10 is what we call a coefficient. You might say, well, what about this 1,000? Is this 1,000 a coefficient? It's really not. It's not being multiplied times a variable expression. We would call this a constant, but you don't have to know that for now. The book uses an example here of successive circling, they call it, to help identify structure. If it's helpful, you can use it. If not, you don't have to worry about it. But if you go through the order of operations, you do parentheses first, and so you can see they've circled the parentheses. Then you do exponents, so then we would do this part of the problem next. Then we multiply and divide. So then we would take that answer times the 5 and this answer times the 10. And you see what we're left with then is just the terms. We have this plus this. So we have two terms. And if we look in a little closer, this 5 is a coefficient and the 10 is a coefficient. So in this case, we have two terms and two coefficients. Go ahead and pause the video here and just go through these three and identify your terms and your coefficients. If it helps, you can use the circling. Okay, so here, if I circle, that's my first thing. I'm going to do parentheses, then I'm going to do exponents, and then I do multiplication. We can see our coefficient here, and that really leaves us with two terms. So term 1, term 2, and one coefficient. So I have here two terms and one coefficient. In this case, if I knew what A was and I was going to do order of operations, I would have to do this first. Just a quick point out, some of you might think, well, I would distribute. And a lot of times we would just distribute the 5A in, but that's really a way around the order of operations. If we knew what A was, we would first add 9 to it, and then we would multiply it times 5 times A. In this case, I'm just going to stop here and say, okay, we have to do our exponents next. A question comes up, is the A a coefficient? It's really not. This is really one term, and this is another term. And this term has 4 as a coefficient, and this term has 5 as the coefficient. Okay, so this one term is made up of 3 numbers multiplied together. Do you see that? We have 5 times A plus 9, and the 5 in the front is a coefficient. All right, next problem here. This is interesting. If we knew what B was and we were going to calculate it, we would start with our parentheses. So we'd take this times this. And then we don't have any exponents. The next thing we have is multiplication. We have 6 times this number times this number. And so we really end up having one term. But inside that term, we have 2 other, I guess binomials is what they're called. But we just have 3 numbers multiplied together. The 6 here, do you remember what that's called? Coefficient. And so we have one term, and the coefficient of that term is 6. And that is the end of this video. So just looking again at structure is helpful.